When you walk into a beautifully designed modern home, uh, you flip a light switch and the room just floods with light.
Right. It just works.
Exactly. You don't think about the wiring in the walls. You certainly don't expect to have to, like, physically hold the power plant and the entire city electrical grid in your hands just to make that one little bulb turn on.
No, that would be completely unmanageable.
Yeah. You want the infrastructure to be invisible. But in the world of software architecture, especially in strictly pure programming paradigms, developers often find themselves accidentally carrying that entire power grid around literally every single time they want to flip a switch.
Yeah. It creates this incredibly tangled, exhausting mess.
It really does. And, you are here listening to this deep dive because you want to understand the deeper architectural currents that drive software design without getting bogged down in superficial summaries. I'm your host, and I'm joined by our resident architecture expert.
Hi, everyone. Really excited to be here.
And today we have a fantastic architectural mystery to solve that strikes at the very heart of how we structure logic. So what are we looking at today?
We are looking at a very specific, revealing piece of source material today. It's a blog post published today, actually, August 14th, 2026, by a developer named Ang.
Okay.
And it is part of a really long-running series. It's titled Notes on Haskell-Programming, Part 213, When Your Haskell Code is Suffering from Parameter Drilling Anti-Pattern.
Wow, part 213. That indicates a serious commitment to the graph.
It really does, yeah.
But just so you know, you don't need to have read the previous 212 parts to extract massive value out of this. Our mission for this deep dive is to completely decode this concept of the parameter drilling anti-pattern.
Right, which you might also hear referred to as prop drilling or manual dependency injection.
Exactly. We are going to figure out what it is, how it slowly and silently infects a code base, and why it can turn, relatively simple piece of text conversion software into a completely tangled web.
And more importantly, I think, we're going to look at why developers fall into this trap, often while they're actually trying to follow best practices.
Okay, let's unpack this. So, where does this infection usually start?
Well, the infection almost always starts with good intentions. It stems from a desire for absolute transparency in the code.
Transparency, right.
Yeah, because in functional programming languages,
Mm-hmm.
like Haskell, the whole philosophy is that a function should be pure.
Meaning it shouldn't secretly pull in global variables or like hidden state from the environment?
Exactly. Everything a function needs to do its job must be explicitly handed to it as an input parameter. And Ang's post provides a perfect case study of how strictly adhering to that rule slowly degrades the entire architecture of an application.
Let's start right at the source of the infection in Ang's code then. Because every good software mystery starts with a piece of data that gets a little too big for its britches.
Yeah, it does. In this case, it is a monolithic block of configuration data. Ang is building a tool that converts text files into ebooks, and there is a core data type defined called the args record.
The args record. So what's inside that?
It's designed to capture all the arguments a user might pass in from the command line interface. It bundles together 7 specific fields.
7 fields. Okay. Give me the rundown.
Sure. So you have an input path, which dictates where the source file lives. You have an output format for the ebook.
Okay, those are pretty standard.
Right. Then there's a verbosity level to control how much logging the program spits out. And then there are a few Booleans.
Like what?
There's a debug mode, an auto-open flag to launch the book after it's built, and a tidy flag to clean up temporary files.
Got it. That's 6.
And finally, there's a publisher text field.
Okay, I mean, grouping those together makes logical sense. It is a neat little package of configuration options. The issue isn't the existence of the record, right?
No, not at all.
The issue is the logistical nightmare of moving this record around. Because Haskell demands explicit data passing, Ang is threading this massive args block through the entire text conversion pipeline.
Right. Every single layer of the application takes this monolithic record as a mandatory parameter.
Yeah, looking at the source, we see type signatures for 3 core functions. There's pipeline, parse input, and convert to ebook. And sitting right there in the signature for every single one of them is the requirement to provide the whole args record.
And to actually use the data inside that record, the code utilizes pattern matching.
Which is pretty common, right?
Oh yeah, Pattern matching is a fundamental mechanism in Haskell. It allows a developer to unpack a data structure by basically saying, I expect this record to have these fields, and I want to assign these specific internal pieces to local variables so I can use them.
But Ang is forcing this unpacking process to happen down the entire pipeline.
Yes, exactly. The parse input function reaches into the args record to pull out the input path, the output format, and the tidy flag. But then later on, the convert to ebook function unpacks the input path, the verbosity, the output format, the tidy flag, AD the publisher.
Let's ground this in a physical analogy for a second. This sounds like packing a massive, 100-pound suitcase for a weekend trip.
That's a good way to look at it.
But instead of leaving it in the hotel room, you are forced to physically carry it into every single room you enter. The restaurant, the museum, the lobby.
Right, it goes everywhere with you.
And you don't just carry it, you have to physically open it up, rummage through all your clothes and shoes just to pull out your toothbrush.
Exactly. And it's actually worse than just the annoyance of carrying it around.
How so?
Well, if you decide to add a hairdryer to that suitcase, the suitcase gets bigger. Now, you might have to physically widen the doorway of the restaurant just to fit the suitcase inside.
Even though you have absolutely no intention of drying your hair while eating dinner.
Precisely. That is the core of the coupling problem. You are forcing every location to deal with the whole suitcase.
Ah, I see.
If you modify the args record by adding a new command line flag, say a font size preference, the compiler forces you to update the pattern matching in functions that couldn't care less about font sizes.
Wow.
Yeah, the monolithic args record creates unnecessary coupling across modules that really should be completely independent.
But wait, I have to push back here for a second. If we are talking about functional programming, explicit data passing is the whole point.
It is, yeah.
We want that strictness, right?
Yeah.
You want the compiler to know exactly what goes into a function and what comes out. If a function needs to know if debug mode is on, it has to be passed in. Why is this suddenly being labeled an anti-pattern? Isn't Ang just following the fundamental rules of the paradigm?
What's fascinating here is where that line gets crossed. Explicit data passing is indeed fundamental to functional programming.
Right.
But it crosses the line into the parameter drilling anti-pattern when it forces functions to possess knowledge about data they do not actually care about.
Oh, I see.
When the parse input function is forced to accept the entire args record, it becomes tightly coupled to the existence of a publisher field or an auto-open flag.
And those have nothing to do with parsing text.
Exactly. Those fields have absolutely nothing to do with the mathematical logic of parsing text into a data structure. The function's signature is essentially lying.
Lying.
Yeah, it claims to depend on the entire configuration when its true logical dependency is just a tiny fraction of it.
It creates an artificial dependency. If the doorway is too small for the newly expanded suitcase, the function breaks, not because its internal logic failed, but because the delivery mechanism got too bloated.
Exactly.
And building on that idea of carrying unnecessary baggage, Ang points out something even more structurally damaging. What happens to the intermediate hallways, the functions that act as middlemen?
Oh, this is where parameter drilling shows its most insidious side. It's the degradation of the orchestrating layers.
Right.
Ang highlights a function called pipeline in the XS2 ebook /app.has module.
Okay, the pipeline.
This function acts as a high-level orchestrator for the entire application. It accepts the args parameter, but it never unpacks it.
Wait, it doesn't use it at all.
It uses absolutely none of the fields itself, zero. It purely accepts the args record so that it can delegate it. It re-drills it down into the relevant subfunctions like parse input and convert to ebook.
So it just takes the suitcase at the front door and hands it to the next function down the hall.
Yep.
Which means if the final destination function needs a new piece of data, you don't just update the destination, you have to update the middleman too.
You do.
You have to drill a new hole through every layer of your architecture just to pass a wire down to the bottom floor.
And it gets weirder. Ang discovered a bizarre consequence of this constraint in the codebase.
Yeah.
It's a complete architectural round trip.
A round trip. What does that mean?
Well, it requires understanding a bit of type-driven development, which is a popular methodology in Haskell. The goal is to, quote, make illegal states unrepresentable.
Okay, so a developer wants the compiler to prove that data is valid before it moves forward.
Exactly. So let's trace the life cycle of this args record. The orchestrating pipeline function receives args and passes it into parse input.
Right. Hand the suitcase over.
Parse input does its job and generates the parse content. But because the subsequent functions in the pipeline still need that monolithic args suitcase, parse input can't just return the parsed text.
Oh, so it has to return the text and the
Yeah.
suitcase. So the developer decides to use the type system to guarantee that the suitcase has survived the parsing stage.
Exactly, the motivation. Parse input takes the args, does its parsing, and then stuffs the args inside a brand new data wrapper called valid input.
Okay, so a new data wrapper.
Yeah, and it specifically places it under a field named vargs. The developer is trying to use the type system to say, hey, this configuration is now part of a validated state.
Got it.
And then that valid input wrapper is passed back up to the pipeline middleman.
So it literally stashes the suitcase inside a bigger box.
Right.
Then the pipeline middleman receives this box, reaches into the valid input, and extracts the exact same args record back out.
Yeah, now renaming it vargs in the code.
Just so it can immediately turn around and feed it into the convert to ebook function.
Yes. The data hasn't changed. Not a single byte of the configuration was altered. It was just smuggled through the parsing layer because the architecture demanded that everything be passed explicitly down the chain, step by step.
That is wild.
The developer was trying to use strong types to ensure safety, but ended up contorting the application flow just to appease the compiler's demand for explicit threading.
That sounds absolutely exhausting from a maintenance perspective. You're writing boilerplate code just to shuttle data in and out of wrappers, rather than writing code that actually does the work of converting text to an ebook.
It really is a logistics nightmare disguised as strict software engineering.
Yeah, because the true logic of the application gets completely obscured. When you look at the pipeline function, you shouldn't be seeing data shuttling mechanics and wrapper extractions. You should be seeing the high-level business logic.
Exactly. The parameter drilling drowns out the signal with logistical noise.
And the infection doesn't stop with passive configuration data like the args record, right?
No, it doesn't. Ang's post reveals how parameter drilling actually spreads to the active tools, the core operations and dependencies the functions need to execute their logic.
Like manual dependency injection gone wrong.
Yeah, the concept of manual dependency injection starts to clutter up the most basic capabilities of the software. Let's look at the print content function in the XS2 book/reader.hs module.
Okay, print content. Sounds straightforward.
Its goal is incredibly straightforward. It prints out content to the screen.
But according to Ang's notes, it forces the caller to provide 3 completely unrelated parameters just to execute that simple action.
Right.
First, it requires stutter. In systems programming, standard error is a low-level stream reference, a handle used for outputting error messages or diagnostics.
Good.
Second, it needs the verbosity level. And third, it needs doc, which is a pandoc object, the actual data structure representing the document being converted.
Just consider the friction that creates for anyone trying to maintain this code. In a less strict language, if a module deep in the system needs to print a warning, you just call a global print function.
Right, simple.
But Haskell isolates side effects. Printing touches the real world. It modifies the terminal. Because of that strictness, a function can't just secretly print. The caller has to magically source these specific dependencies.
So if a new module wants to print,
It has to find the system stritter handle, figure out the current verbosity state, and manually pass them in.
here's where it gets really interesting, because we are no longer just carrying a suitcase of clothes. The analogy shifts.
Oh.
This is like hiring a professional plumber to fix your sink, but their contract states that you have to provide the wrench, you have to source the specific replacement pipes from the warehouse, and you actually have to manually guide their hand while they do the turning.
That's spot on.
You are essentially doing the plumber's job for them. The caller is managing the internal tools of the function.
You are managing the dependency graph manually at the call site every single time. And it gets even more complex and leaky when we look at process runners.
Process runners, okay.
Ang brings up the open ebook function. Its job is to interact with the operating system to open the newly generated file. It requires the caller to manually inject the tool that runs system processes.
So it takes a function as an argument.
Exactly. It takes a function called call process as an argument.
Passing a function into another function is standard functional programming. But the resulting type signature for OpenEbook is incredibly noisy. It demands a function that takes a string and a list of strings and returns an I/O action.
Yeah, and the term I/O action is crucial here. In Haskell, I/O is a contamination tag.
A contamination tag.
Yeah, it is the language's strict wall against side effects. If a function returns an I/O action, it is loudly declaring, hey, I interact with the messy, unpredictable real world outside of my pure mathematical logic.
Wow.
So the signature for OpenEbook literally looks like parenthesis, string arrow, list of strings, arrow, IDO unit, parenthesis.
Instead of a clean signature that says, give me a file path and I will execute the open command, the signature screams about the internal mechanical tools it needs.
Exactly.
It leaks its implementation details out to the caller. The caller has to know that OpenEbook uses a specific type of process runner that requires a string executable and a list of string arguments.
It completely violates the fundamental idea of abstraction.
Yeah, the caller shouldn't need to know how the ebook is opened, just that it gets opened.
The caller becomes inextricably linked to the implementation details of the Kali. And the final example Ang gives is perhaps the most frustrating from a pure logic standpoint,
Why is that?
because it shows how third-party libraries can force developers into this anti-pattern. It involves the parse function in the reader module.
Okay, parsing text into a structured document is a core, mathematically pure operation.
It is. The function takes the text content, which is represented as a byte string. A byte string is just a highly efficient sequence of bytes in memory. It's completely decoupled from any file system. But the parse function also demands a file path parameter, named path.
Well, you would assume the parser needs the file path to open the file and read it, right?
You would think.
Yeah.
But the file has already been read. The text is already loaded into that byte string memory array.
So why does it need the path?
The parse function demands the file path merely so it can label the source positions in its error messages.
You're kidding.
Nope. It uses a library that formats errors, and that library demands a file path to generate a clean string like error on line 5 of document.txt.
Unbelievable.
It calls a function initial pos path just to satisfy that error formatter. The file path has absolutely nothing to do with the actual computational logic of parsing the byte string content.
So if I just have a raw string of text in memory that I want to parse, maybe like a user typed it into a web form so there is no physical file on a hard drive, I can't easily use this parse function without faking a file path?
You would have to pass in a dummy string like dummy.txt just to satisfy the compiler.
That is a massive red flag that the function signature is demanding more than its core logic actually requires.
Yeah, the error reporting mechanism has been awkwardly bolted onto the parsing logic through parameter drilling.
Wow.
The developer is forced to thread a completely irrelevant piece of data all the way from the front door of the application down through the middleman just to appease an error formatter at the very bottom.
So what does this all mean? We've gone deep into the architecture of Haskell-type signatures, the strictness of explicit passing, and the mechanics of manual dependency injection.
We really have.
We've seen monolithic suitcases of config data being smuggled through wrappers and plumbers demanding that you provide the wrench. When we step back from the code, what is the ultimate takeaway?
Well, when you synthesize all these examples from Ang's post, the core diagnosis is that the parameter drilling anti-pattern fundamentally obscures the actual purpose of your software.
It really hides the logic.
It takes clean, logical operations and drowns them in logistical noise. It creates bloated type signatures that are hard to read and, honestly, even harder to maintain.
Yeah, that makes sense.
Most importantly, it tightly couples your modules together. When an entire system shares the exact same monolithic dependencies passed by hand, you cannot change one piece without untangling the whole knot. You lose the ability to isolate and test components independently.
Right.
Ang's post is making it clear that recognizing these symptoms is the critical first step. Future posts in the series will actually cover the cure how to refactor this code using more advanced functional techniques, like the reader monad, to invisibly thread dependencies without the boilerplate.
For you listening to this, whether you are writing code daily, designing complex system architectures, or just fascinated by how rules shape behavior, there is a massive lesson here. It is the ability to recognize when a rigid best practice turns into a bottleneck. Explicitly passing data is a fundamental best practice in functional programming. It makes things predictable and testable. But as we've seen today, when that best practice is applied blindly, without considering the cohesive boundaries of your logic, it mutates into the prop drilling anti-pattern. The tools end up dictating the architecture. Recognizing that tipping point when the boilerplate outweighs the benefit is a crucial architectural skill.
If we connect this to the bigger picture, it really forces us to examine the underlying philosophies of the paradigms we trust. The symptoms Ang documented, the round trips, the middleman forwarding, the cluttered signatures leaking implementation details. They didn't happen because a developer was lazy or trying to write bad code.
No, quite the opposite.
They happened because a developer was trying incredibly hard to strictly follow the rules of pure functional programming. They wanted the compiler to prove everything was safe and explicitly defined.
Which brings up a really provocative thought to leave you with today. If pure functional programming inherently discourages hidden states, global variables, and side effects, demanding that absolutely everything be passed explicitly in the open, does the paradigm itself actively push developers into the parameter drilling anti-pattern?
It's a great question.
Are we forced to choose between purely defined code on one hand and readable, decoupled architecture on the other? Or is there a hidden third way? A method to maintain strict mathematical purity without having to carry the entire power grid in our hands just to turn on a single light?
That is the multi-million-dollar architecture question right there.
Something to mull over the next time you find yourself passing a single piece of data through 5 layers of a system just to use it once. Keep exploring, and we'll catch you on the next deep dive.